Yeah.
Okay. Well, I'm disappointed that this hall isn't crowded with people, but we're going to video this. And the first talk I intend to give will be about. I'm going to do, and incidentally, I'm going to do these talks once a month in this hall. So this is the first set of lectures, and they're going to go up on the internet. So they're all being videoed, and they will be up for anyone to look at afterwards. I have two things that I want to talk about, which are quite important. Well, one of them is, the other one is interesting. The first thing I want to talk about, and the first lecture, and then there'll be a break, will be about the genetic effects of ionizing radiation. Now, I've studied the effects of ionizing radiation for 25 years, maybe a bit longer. And recently, together with some colleagues in Germany, I published a paper in a major scientific journal, which suggests that the genetic effects of radiation, particularly internal radiation, are serious, much more serious than is currently understood by the radiation risk models which exist and which are enshrined in law. So in other words, you have legal systems which say that you can't have more than a certain amount of radiation, and this level is set by reference to the International Commission on Radiological Protection, which is an organisation which began in 1952. Now the problem is that the basis for the radiation limits, the laws that regulate the amount of radioactivity that you can be exposed to, these regulations turn out to be quite wrong. And how do we know this? Well, we know this from the effects of Chernobyl. And in this article, which I will now refer to and talk about, I will explain what's happened. Now, most people know that life has evolved with radioactivity. In fact, everyone learns in school that life has evolved on a radioactive planet. We are exposed to cosmic rays and gamma radiation from minerals containing uranium, thorium, and various other radioactive materials, potassium, for example. Now, ionizing radiation harms all living systems by causing mutations. We say that it's genotoxic. In other words, it affects the gene, it affects the DNA. And the result of that is cancer, birth defects, infertility, and the introduction of...
Take that one, then you can be free.
Okay, all right. Okay, oops, yeah.
Dat box kan je dan, ja. Nee?
Right, the genetic damage, the mutations to the DNA, these effects result in cancer, they result in congenital malformations if it's germ cell DNA, and of course a whole range of birth defects, and of course infertility too. Now, since the development of nuclear weapons after the Second World War, after 1945, what we saw was an enormous increase in radioactivity released to the environment from all the weapons, from the nuclear weapon testing in the atmosphere. So since then, the world has become contaminated by a whole spectrum of radioactive elements like strontium-90 and cesium-137, and of course uranium. Because uranium is normally, throughout history, throughout evolution, it was locked in the soil, in minerals. But since about 1910, it's been dug out and it's been refined, and when it fissions, it turns into all of these radioactive substances, many of which are rather like the same substances which living systems incorporate into their bodies. For instance, carbon-14 and tritium, which is a radioactive form of hydrogen. And some of them bind to DNA. So uranium, for example, binds to DNA, and so does strontium-90 and barium-140 and all of these chemical elements which are in group 2. Now, the result of this contamination of human beings and living systems is that introduced into the genome, introduced into the genetic structure of all living systems, which have developed over evolutionary timescales, has introduced mutations, a higher level of mutations. And the results of this can be seen in higher levels of cancer, higher levels of genetic damage, as shown by stillbirths and infertility and so forth. And all of the research that's been done on these congenital effects of radiation were reviewed by us and published last month in a journal. Published last month in a journal called Environmental Health and Toxicology. And this is the journal, if you're interested. These are the people, myself, Inga Schmitz-Feuer, professor of physics at the University of Bremen, and Sebastian Goodbar, who is the president of the German Society for Radiological Protection. And here are the details. If this is on YouTube, you can see, you can download this and see what it is we found. Now, the first evidence that there was a problem, a genetic problem with the radioactivity, was an increase in infant mortality which occurred over the period of the nuclear weapon testing in the atmosphere. This is from a paper here that was published in 1992 by Robin White, who's a paediatrician from Canada. And you can see that the fall in infant mortality and the fall in neonatal mortality and stillbirth in the United States. And she also looked at Europe and she looked at the United Kingdom. And you can see this effect, where there's an increase in infant mortality that's associated with exposure to the internal strontium-90 and the other radionuclides that were produced by these weapons testing, which went up into the atmosphere and then came down with the rain. So in high rainfall areas where there's a lot of rain, you get higher effects. Now this is work that I did in the 1990s. It shows that the heavy black line shows infant mortality from congenital heart defects. So if you're something wrong with your heart, you get various heart defects in developmental stages of the embryo. And you can see that it correlates quite well with the dotted lines, which are strontium-90 precipitation in the United Kingdom. So this is all United Kingdom data, but it's official data, and you can see the peaks associated with the strontium-90 in the milk, the strontium-90 in the bones of the children. It was measured in the bones of the children, and so it's killing these children by causing heart defects. Now, the risk model that says that this is impossible is the risk model of the International Commission on Radiological Protection, which used to be in Sweden, but it now is moved to Canada. And from 1952 onwards, it stated that there was no evidence at all that radiation caused any sort of genetic damage effects in human beings. And so what the ICRP have done in order to regulate the levels of radiation as far as heritable defects and genetic damage is concerned is they have taken their data from experiments on mice. So the ICRP say there is no effect on human beings, and they still say that, and that their risk model says that you have to have 1,000 millisieverts to get a doubling of risk of congenital malformation. And they based their data on the Hiroshima study, the study of the survivors of the Hiroshima atomic bomb. And those people said that there was no increase in any congenital malformation in those people who were exposed to radiation after the atomic bomb. And as I said, it's the basis of all current radiation risk estimates, not just for congenital malformations and heritable defects, also for cancer, is the study by the United States-Japanese Atomic Bomb Casualty Commission. Now what those people did is in 1952, that's 7 years after the bomb went off, they recruited a number of people from Hiroshima and Nagasaki, and they separated them into various dose groups, high dose, medium dose, and low dose, according to how far they were away from the epicenter of the bomb. So if you were 1,000 meters from the bomb, it was a high dose group. If you were then 2,000, it was a medium to low dose group, and 3,000 was a low dose group. And so they had these 3 dose groups, and they also had a control group which was not in the city. So these are the people who weren't even there when the bomb exploded, and they came into the city between 3 weeks and 3 months after the explosion. So this was the proper control group. But what happened was that when they started to analyse the data in the 1960s, they found that there was in fact quite a serious effect when compared to the control group, the people who were not in the city. So what they decided then was that the control group was an especially healthy group, and they abandoned it. They threw it out. They said, we're not going to do anything about the control group, we're going to put it to one side, and we're going to just compare the high dose, the medium dose, and the low dose groups. And of course, this is not very good epidemiology. And as a result of this, of course, they didn't find any increases in congenital malformations because they were comparing people at different dose levels. And of course, if you're looking at congenital malformations, you have to say that as the dose increases, what happens is the baby dies in the womb. So you're not going to see any congenital malformations because there are no babies. So, as I say, in epidemiology, you have to compare a group which is exposed to the radiation, in this case, to one which is not exposed. So after the data was analysed, and it became clear that the exposed groups, when compared, but the not in situ control group, would give an effect on cancer and birth defects, they discarded the NRC group on the basis that it was too healthy. Now, this is an astonishingly bad piece of epidemiology, and you have to say that it might border on criminal behaviour, really, because as a result of this, we have had 70 years of exposure of the human race to substances which actually have been killing them and causing high levels of cancer, and are probably the cause, almost certainly the cause of the current cancer epidemic. There were effects also found to be on sex ratio. So if you have genetic damage, then the number of boys to the number of girls alters. And a lot of work has been done on this, and work was done on Hiroshima survivors also, that there was a perturbation in the sex ratio, so there was a change in the number of boys born to the number of girls. But they discarded that also, because it wasn't in the direction they expected. And the man who discarded it, who was the director of genetic research for this AB's Atomic Bomb Casualty Committee, was a man called James Neal. And Neal was later accused of doing genetic experiments on South American Indians, which resulted in the death of a whole tribe of South American Indians that he injected with smallpox virus, on the basis that he wanted to see whether or not the stronger people in the tribe would survive, because he had this idea that strong people, by which he meant men, I guess, with big muscles, the chiefs and the people who were more or less in charge of the tribe. He thought that those would survive, and the people who weren't strong would die. But of course, it was just random. So in 1959, the evidence started to become clear that there were genetic effects and that there were increases in leukemia in particular. So at that point, the authorities, the United Nations, took the research from the World Health Organization. The research into radiation was taken from the World Health Organization, and it was handed over to the atomic scientists at the International Atomic Energy Agency. Now, the remit of the IAEA is the development of nuclear power. And so obviously putting into the hands of these people the research on the health effects of radiation was really quite wrong, really quite biased. And as a result of the IAEA now being in charge of the health effects of radiation, what we have found is that they have been covering up the effects of Chernobyl and covering up the effects of Fukushima. In fact, an organization called the Independent WHO set themselves up in Geneva. And what they do is they stand outside the WHO every single day, from 8 o'clock in the morning to 6 o'clock at night. There's somebody having a constant vigil every single day since 2009. They've been standing outside the WHO with a board saying that the WHO crooks and the WHO should all be sent to jail.
But they have also the best conferences.
Yes, we've done some conferences with them. Okay.
Not only activists.
No, I'm going to. For those of you scientists who are here, the physicists, if you want to see what it is that we have discussed in order to work out the genetic effects, the risk factor for the genetic effects of radiation, you must look at the paper. And I'll just briefly go through some of the things that we have looked at. Most of what the paper is reviewing is research into the health effects of the Chernobyl accident in different countries in Europe. And it is quite astonishing that the ICRP and the IAEA have completely and utterly ignored all of the evidence that is published in the peer-reviewed literature and also in the Russian language peer-reviewed literature, showing that the health effects of really small amounts of radioactivity from the Chernobyl accident have caused big increases in congenital malformations at very, very low doses. For example, Hoffman in 2001 reviewed congenital birth defects from Turkey, Bulgaria, Croatia, Germany, Belarus, Finland, Norway, all at doses less than 0.5 millisieverts. Now you might wonder how this could possibly happen at 0.5 millisieverts, because of course the natural background radiation levels in most countries are about 2 millisieverts, so 0.5 millisievert is about 1/4 of the background radiation. So you could argue, and they do argue, that it's impossible for these effects to occur at such small radiation levels. But the problem is dose. The problem is the concept of dose. Because if you have a radionuclide like strontium-90 or uranium, which exists in the body as a uranium, these substances bind to DNA. They have strong chemical affinity for DNA. So it's not possible to employ the concept of dose to discuss the effects of substances which bind to DNA, since DNA is the target for these effects. And we know this is true from all sorts of experiments that have been done in cell cultures, and also experiments that are done with animals. So let's go on. In Belarus, Lazaruk in 1997 looked at the pathology of legal abortuses. So those people, they looked at all of the babies that were removed from their mothers as abortions to see what kinds of genetic damage there was in those fetuses. And he compared 1987 to 1994, that's the period after Chernobyl, to the period before Chernobyl, 1982-1985, for a number of congenital malformations. Anencephaly, that's they're born without a head. Spina bifida, left lip polydactyly, that's like 6 fingers, 7 fingers. Limb reduction defects, there's people with like no feet, they just have little limbs, and like people with who used to take that drug. Then esophageal atresia and erectile atresia. So they don't have an esophagus, they don't have an anus, and multiple malformations, and of course Down syndrome. And he found that there was 80% excess at 7 millisieverts, 50% excess at 0.4 millisieverts. So again, we've got these tiny little doses, big level of congenital malformations. And then another Belarusian, Feshenko, they did the same thing. They looked 1987 to 1986, so they're looking after Chernobyl and comparing with before Chernobyl. Again, they're looking at the aborted fetuses, and they're finding an 86% of malformation in the contaminated regions and a 60% in the less contaminated regions. Let's go on. But Feshenko also looked at chromosome anomalies. So they also find that there was 4.5 times more chromosome damage. That's dicentric rings or centric chromosomes. That's damaged chromosomes, ones that instead of being like this, they go like this and they go like this and come out. So you've got this sort of chromosome. And they can see these with a microscope. They just look at them. Okay? And so they had 4 times more chromosome damage in the contaminated regions, Gomel and Mogilev. Now Sevchenko, who worked for UNICEF, he wrote a book in which he said that the frequency of congenital malformations reflects pollution levels. So he had a 5.6-fold excess in Vetka, 1.7-fold in Dobruch, and so on and so on. I mean, I could go on and talk about these forever. So there's another one here with Petrova and Kulakov, also showing high levels of congenital malformation when you compare after Chernobyl to before Chernobyl. So you don't want to hear all of these because it just goes on forever. One of the most important studies was a study by Vladimir Vertelecki. Now he and I are writing to the Lancet at the moment to challenge the editor of the Lancet to give us an edition of the Lancet to write all this stuff into. Because this is a very, very serious problem, and at the moment it's being kept out of the literature, the big scientific literature, the Lancet and Nature and so on. And I've got together with a number of other scientists. Vertelecki is one of them, Yablokov is another one, and the people that I published this with do. What they did is they looked in the Ukraine, in the Polisia region, which is draining the Pripyat marshes. So there's a lot of radioactivity from Chernobyl there. And they did an enormous study, and they did it very carefully. And this guy is in America, this guy Vertelecki. And they looked at 145,000 births from 2000 to 2004. And they found significant excess risks in the radioactive area compared to the non-radioactive area. And they actually also measured the radioactivity in the mothers of the congenital malformation children. So they know what the doses are, and the doses are approximately 6.7 millisieverts, low doses. This is the cumulative dose to the mother over 12 years since the Chernobyl accident. So it's not like the dose to the fetus, it's the dose to the mother over that period of time. Now it's not just in Belarus and the Ukraine, it's also their effects found in Turkey. Here we go, and this chap Akar, he looked at 90,000 births in the Bursa region of Turkey. He found anencephaly neural tube defect rates increased from 1.7 to 9.2 per thousand births at a dose of less than half a millisievert. And other people in Turkey also, you can see them all there, and I won't bore you by going through all of them. But there's an awful lot of research that has now been published that shows that these effects are occurring at very, very small doses. By comparing after Chernobyl to before Chernobyl, we can see these sudden increases in congenital malformations. I myself studied infant leukemia in Germany and Greece and the United Kingdom and found big excesses at the same sorts of very small doses. And various people have studied radioactive parts of Germany too. Now there is other evidence, of course. There are people who live near the Soviet nuclear test site in Kazakhstan. They found increases in congenital malformations in Down syndrome, microcephaly, that's a very small head, and multiple malformations. There was a study in Montreal of mothers who had been x-rayed for their pelvis, for the people who have x-rays of the pelvis because they've broken their legs, and they found a high level of increase in congenital malformations in those children, because of course in the children of those mothers, because the eggs had been exposed to the x-rays when they were x-raying the hip. I've done a study of the UK nuclear test veterans. Now those were men who were stationed in the Pacific when the British were testing their nuclear bombs, and we found a very high rate of congenital malformation in the children of those people. That's been published in the peer-reviewed literature, but we also found in the grandchildren. So if you looked at those men who were stationed out there, they came back and they had children with congenital malformations, and the rate of congenital malformations relative to the national population and to controls, because we did a control in that study, was 9-fold. There are 9 times the congenital malformations in those children, but extraordinarily also in the grandchildren. So the grandchildren had an 8-fold excess of congenital malformations. And of course there's the famous study by Alice Stewart, who showed that there was a 40% excess risk of leukemia after a dose to an eye of 10 millisieverts. So what do we conclude from this? Well, we conclude that the ICRP risk model is in error by about 1,000 times. It's not a small amount. This means that you're getting an increase in congenital malformations from internal radiation at doses of half a millisievert. Now, what the ICRP says as a result of their dependence on mice they say that you need to have 1,000 millisieverts to get a doubling of congenital malformations in the children mice, and so that's been taken over to humans. So the law is out by a factor of 1,000 times. And so the current legal perception is unsafe. Why should we care about this at this stage? You know, here in Latvia, why am I in Latvia talking about this? Well, partly because I live here, but partly because actually Latvia can do something about it. And in fact, small countries around all of the Baltic state countries, Lithuania, Estonia, or in fact Germany, of course, not a small country, and Denmark, all of the countries on the Baltic Sea are living in the most radioactive sea in the world. As a result of the injection into the Baltic Sea of material from Chernobyl and material from the nuclear weapons tests, there's a very high level of radioactivity in the Baltic. This is a map that was produced by Helcom in Helsinki, and it shows that there's about 500,000, you can see here, 50,000 to 100,000 becquerels per square meter here in the silt of cesium-137. And so when the wind blows and the sea washes into waves, this stuff comes ashore, and people who live near the coast, they get sick. This is how the radioactivity got into the Baltic Sea. This is also from Helcom. It shows the increase in the inventory. You can see here, this is 1986 there, that's when Chernobyl was, and this stuff here, of course, is from the weapons testing, mainly from the Russian nuclear weapons testing, but also from America.
And it's both sediment and seawater.
Yeah, and you can see here too that actually there was a direct track. These are tracks that show the developing movement of the radioactivity from Chernobyl on the first 6 days after. And you can see one of those tracks there on the 27th and the 28th and the 29th. It came right across, really just south of Riga. You see that one? And there's another one that goes just north of Riga. So there's no doubt, whatever you've been told by the people who study who measure the radiation here, there was a large amount of radioactivity that came from Chernobyl across Latvia. And it went into the Baltic Sea, and it contaminated the diabaga, and it contaminated the people. And almost certainly you will find effects here in cancer and other ill health. And mainly the problem is these radioactive particles, these fuel particles. This is a radiograph of a skirt of a woman, a woman's skirt, a woman who visited Kiev about a week after the accident. This woman then also, she was a radiographic person, she brought her skirt back to England, and they put it on a piece of X-ray film, and this is what they saw. So these little particles fly about the place, and you inhale them, they get inside you, then the uranium concentration increases, and then you get ill. So we end up this first talk with the conclusion that the ICRP model must be abandoned, because otherwise there will be more sick adults and sick children. And the way in which the Latvians can do something is through the Espoo Convention. So what we have here is that the Swedish government is proposing to build a high-level nuclear waste dump on the shores of the Baltic Sea. This is the report that we've already considered. It's the environmental impact statement of the Swedish company SKB, who is building this enormous high-level waste repository on the shores of the Baltic in Forsmark. And there is a convention, the Espoo Convention, which says that people who might be affected by any development to do with the Baltic Sea can say no. They can veto this. So the Latvian government can veto this. They can say, we do not want you to increase the concentration of radioactivity in the Baltic Sea because it's quite bad enough as it is. And there's all this new evidence on congenital malformations that have now been published in the peer-reviewed literature, and it doesn't. And you don't have to just listen to what that guy Busby says and and his colleagues, because you can look at the paper and you can see an enormous list of research from different countries in Europe that show that these low doses of fishing products are actually killing people. So that's the end of my first talk. And I think probably, what shall I do? Shall I just blast straight into the next one? Or do people want to stop and have a wee and drink some water and stuff? What do you think? I mean, I've got enough energy to just...
Excuse me, but pause it, but they don't want to pause. I'll just start a new session.
Because I want to talk about something much more interesting than radiation.
The nuclear savings, that's done already. Well, they started many years ago. Forsmark by...
Oh no, they're still, they haven't made a decision yet, have they?
Well, I was there from when I was in school, and that's 20 years ago.
Yes. No, I'm talking about the waste repository. I mean, the place is there.
That's nuclear waste power
We're
plant.
talking about the development of the
That was
waste
done
repository.
with nuclear waste, where they stored it.
They do store in temporary places, but now they're building permanent.
This is like a huge thing where they drill a hole down about 1 kilometre and they go out sideways underneath the Baltic Sea and have all these tunnels and they put stuff in there and they encapsulate it in copper canisters at Oskarshamn and then they sort of slide it into the tunnels and so forth, you know. So we're still fighting that one. Right. So I'll try next. Can somebody get me a glass of water? I'm a bit thirsty.
Oh, sure.
Just from the toilet.
Це то є приекшую слайду.
Калуджа?
Є приекшую вірно.